So Docker feels like magic, right? You just type one command and you have your own isolated environment. Isn't it cool? You have your own file system, you have your processes, and completely separate hostname from your own machine. But here's the thing, it's not magic, it's just Linux. And in this video, we'll see how you can build your own container runtime just using Bash. Nothing else. No Docker, no fancy tools, nothing. Just Linux kernel primitives, which have existed for decades, really. So at the end, we will have a script under 40 lines, around 35 lines. And with it, we will have our own file system, separate from the host, own processes, and host, which are completely separate from the host machine. So first of all, what are containers? So in very simple terms, a typical container is a isolated environment for your process. Inside the container, the process only sees what you want the process to see. And Linux uses C groups and namespaces to create containers. A namespace is what a process can see. C group or control group is what a process can use. And chroot or change root is for file system isolation. So let's start with our container runtime. To create containers from shell, we will have to use unshare, a command that creates new namespaces. Let's see the man page for that. And it says, as I said, the unshare command creates new namespace and then executes the specified program. If program is not given, then shell is run by default. Okay, let's run it and test. Nothing happened. Basically, what happened is it spawned another shell, and my default shell is ZSH. And if we see F, yeah. So this was my first shell. Then it spawned this, and from there I ran PSF. Okay, and here's the other processes that I'm currently running in the shell. So our host name of the host machine is proxbox, and if we create unshare tag uts and then bash, so now what we did is we specified uts. We used the uts parameter, Unix time sharing system, and what it does is it creates a new namespace for host names and domain names, basically. So in simple terms, man unshare, and if we go to uts, we see create a new uts namespace, and basically it does this, nothing else. And now from here, we change the host name, container, and when we run bash again, we see the host name was changed and the host name is changed. And from another terminal, if we run host name, we see it's still proxmox because the uts namespace was created, but still we can see the files of the host machine, we can see all the processes, and like see the network interfaces and all. We don't want that. So now we can start with the process isolation. PID names. We can use the PID namespace basically. So to create a new process namespace, we can use PID. And if we run PS, we still see all the host processes, right? So what is wrong? So basically, unshare uses exec to modify itself and to run bash. Okay, let's see. We can use strace and unshare uts then ps, and because strace by default outputs to standard error, we will redirect the standard error to temp strace output file. And now when we web exec to temp as trace, we see ps was called by execv, and if we man execv, we see execv executes the program referred by path name. This causes the program that is currently being run by the calling process to be replaced with a new program with newly initialized stack, heap, and data segments. So basically, unshare calls execv to run ps. Unshare gets modified, and that's why we want to use fork. And as we know, fork creates a new child process, duplicating the parent process. In our case, unshare. Now we run bash. Now we still see the processes. So utilities like ps uses proc to get the process information, all the process information, right? And currently we can see that the host shares the same proc file system with the container we just created, but we don't want that. For that, what we can do is mount proc, and with this option we get a fresh proc with just two process IDs, 1 and 2. If we run ps, and if we run ps, we see our bash, which is the main process. So we isolated the process environment, but still we have access to the file system, to the network interfaces. We can ping outside anywhere. So still we have a lot to do. So now we can specify net, and it creates a network namespace, and with IPC isolates the memories, shared memory. Now when we run ipconfig, we see no active interfaces. We list all the interfaces and see we have a loopback interface and nothing else, and we cannot ping because it's isolated. We can definitely configure the network to create a new network just for the container and do stuff like that. Maybe we can do something like this in the future videos. So we still have access to the host's file system. We don't want that. For that, we can create our own file system and use change root to change the root of the container to our file system. For that, first download a file system, and I'm using a Alpine minified rootfs, and so let's create a directory container rootfs tar xvf alpine c container rootfs. Now we have the root file system for our container. Now what we can do is unshare here, and now first change the host name to bash container, then chroot to our container rootfs, then use bin sh as our shell. Now we are inside the container file system, and the container has a proper file system. That's cool. Okay, let's create a shell script with it. First create our rootfs, which is container rootfs. Now we name our container name. We give it bash container. Then we use unshare First we use tuts, then net, then IPC, then for, then we used we used PID, then we used mount, proc, then so I'm running bash, and with C I'm saying okay, execute these commands, and now I'm just saying host name to container name, then I'll say chroot to containers, okay, root fs and bin sh. Okay, we can just run it. Okay, we don't have process. Okay, so what we are missing is so we don't have proc directory. Yeah, we don't have anything in the proc directory. So we have to create a file system because we changed our root to something else, right? And now we don't have a proc, anything in proc. So we will have to create a proc file system. For that, how does mount work? Actually, mount. Okay. Mount type device there. Okay. So as type, I'll use proc. Then as device, I'll use proc. And there will be proc. Root fs proc. Yeah. Now when we run bash container ps, we have we see all the processes. We have proc inside our container. We have proc inside our container, and yeah. So and we can run psfx. So here is the process tree. We started with our script, then it called unshare with these parameters. So this is our small container, and still we have some stuff missing. Like we don't have a proper device directory. We don't have dev null like normal system has. We don't have that. For that, we can create a device node. And here, for that, I have to just create, I think I have to use mknod. Mknod. Yes. Help. So create device nodes, I have to use mknod command, and it takes some arguments. It takes the mode, which mode the file will be created, then the name, then the type, then measure minor. With the measure number, you identify the device driver, and the minor identify the instance. What type of, for example, is it a like bit bucket? Means like so. For example, in we see dev null. So this is the measure number 1, and this is the minor number 3, and C is the what type of file it is. By C we see that it's a character file, it's a character special file, and same for you random. You see the measure number is same, C file type is same, but the minor number is different. 0, yeah, 0 for the 0, it is 5. So we can create it. mknod M666, the devil's number. 666 means this permission, basically read and write permission to everyone on the system. Then we have the name, we have the name, and the name will be root fs dev null. And for null, we have 1 and 3, measure minor. Okay, C and 1 and 3. Okay, nice. Now, when we run bash and do dev, we see null, and we can do something like equal and dev null, and dev null has nothing. So now I can write some cleanup functions and like create all the important like device nodes. I have a copy device nodes, and I can just copy it from here. I can now I can run dev, and okay, I have to call it prepare fs root fs and bash container. Yeah, dev, we have all these files. That's cool. All these files, all these device nodes. We can read from random, and we see it's going bonkers actually. So now also I have to run this. So here I have also written a cleanup container fs. I have to run it. I will run it using trap command, trap cleanup container fs. Cleanup container fs root fs, the file system, and exit. So what trap does it? So trap runs when, so trap will run when you will exit. I can run bash now, or have all the things here. So this was the video on Linux containers, and I hope you liked it. Drop your thoughts below in the comment section. Definitely don't forget to like, share, and subscribe. And do join our Discord. We have around 1600 members. Yeah, take care. Bye.